This is one decimal multiplication problem that might help you. So remember that when we multiply decimals, we always kind of want to estimate our product first. So I know this number is a little more than 3, and this number is a little more than 5. So I'm going to estimate that my product should be a little more than 15. So now, remember, that's our first step to estimate. After that, we're going to basically think of multiplying these numbers as if there were no decimal. So I'm going to think of this as 328. I'm going to think of this number as 51. But we're not really just thinking of that. We actually are multiplying 3.28 by 100 to make it a whole number, and 5.1 by 10 to make it a whole number as well. We're going to come back to that at the end. So it does not matter which type of multiplication you do. You can do lattice, you can do partial products, or what I've heard called the window method, or you can do the standard multiplication algorithm. I usually stick with this because for me it's the least complicated and the most efficient. We're really going for efficiency here. So for doing this algorithm, we're going to start with just our 1, and we're going to multiply 1 times 8, which is 8, 1 times 2, which is 2, and 1 times 3, which is 3. Then when I move to my 5, I'm not really multiplying by 5, I'm actually multiplying by 50. So I have to put a 0 here to force all these products into the next place value so that I'm actually multiplying by 50. So 5 times 8 is 40. Remember, we write the 0 and we carry the 4. 5 times 2 is 10, plus 4 is 14. Write the 4, carry the 1. And 5 times 3 is 15, plus 1 is 16. And we're going to put the whole 16 right there. Now we add these up because this is still partial products right here. 8 plus 0 is 8. 2 plus 0 is 2. 3 plus 4 is 7. 16, well, 0 plus 6 is 6. 0 plus 1 is 1. So I get these digits, and these digits are all part of my product. Remember, we said we think this number is going to be a little more than 15, so I should have an idea of where to place my decimal. But let's be 100% sure. Go back to our original original multiplication problem, and if we look at our multiplicands and our multiplier, I can count that there's 1, 2, 3 digits between both numbers that are to the right of the decimal. That means that when I made these whole numbers, I multiplied by 10 3 times, even if we just kind of did that by ignoring the decimal. So to get my final quotient, I have to imagine that my decimal would be here if this were a whole number. I'm going to divide by 10 3 times, or I can think of that as just moving the decimal to the left 3 spaces. So I get 16 and 728 1/1000ths. That is my final product. And if I go back and reflect on my estimate, yes, that is, like we said, a little bit more than 15. It's actually a little bit more than 16.